Happy morning everyone. In today's lecture, we will see the concept of temperature coefficient of resistance. Before that, we have seen the concept of specific resistance or resistivity of a material. Specific resistance or resistivity of a material is defined as it is the resistance of a material of unit length and unit area of the cross section. It is denoted by letter rho and its SI unit is ohm meter. This resistivity of a material varies with temperature. Consider a conductor of resistance R0 at 0 degree Celsius. That is, R0 is the original resistance of material. Okay, then we consider RT is the resistance at T degree Celsius. T means here temperature. The temperature किती असू द्या because resistance varies with a temperature. Suppose 20 degree Celsius असेल तर at that time the resistivity is the RT or resistance of that material is RT. Then what is the increase in resistance? Increase in resistance is RT minus R0. What is increase in temperature? Increase in temperature is T minus 0 and which is equal to the T. It is the increase in resistance and it is the rise in temperature. Therefore, experimentally, it is found that increase in resistance is directly proportional to the original resistance of that material. Original resistance is here R0 and also it is directly proportional to the rise in temperature. What is the rise in temperature? Rise in temperature is here T. T minus 0 is equal to the T. Therefore, R0 into T. Experimentally, we will get this result. Increase in resistance, that is RT minus R0, is directly proportional to the original resistance R0, you say, or not, into T. T means rise in temperature. Okay. Therefore, RT minus R0 is equal to the, take the constant of proportionality, it is called as a alpha into R0 into T. This is different. This is directly proportional symbol and this is the alpha. And that alpha is the constant. What is this alpha? Alpha is equal to the temperature coefficient of resistance. And it is defined as alpha is equal to the, from this equation, say this is equation number 1. From this equation, what is the value of alpha? Alpha is equal to the RT minus R0 upon R0 into T. This is the expression for alpha. Alpha means temperature coefficient of resistance. And it is defined as, it is the ratio of increase in resistance per unit original resistance per degree rise in temperature. Here small t is nothing but a temperature. This is not the time. Therefore, temperature coefficient of resistance is defined as it is the ratio of increase in resistance per unit original resistance per degree rise in temperature. Then what is the unit of alpha? It is the physical quantity, and what is its unit then? See this, unit of alpha is equal to RT is ohm. Okay, ohm minus ohm. Therefore it is ohm. म्हणजे न्यूमरेटरला जे काही युनिट असेल ते ओहम असणार आहे, डिनॉमिनेटरला युनिट काय असणार आहे ओहम, बिकॉज RT minus R naught is measured in terms of a ohm. R naught is measured in terms of a ohm into T. T is temperature, therefore it is degree Celsius. Therefore ohm get cancelled with this ohm. Therefore SI unit of alpha is equal to the S degree Celsius inverse, per degree Celsius, because here is in the denominator, degree Celsius is in the denominator, therefore its SI unit is degree Celsius inverse or degree Kelvin inverse. This is the unit of alpha, means temperature coefficient of resistance. From equation 1, you get another form which is equal to the RT is equal to the R naught plus alpha into R naught into T. Therefore, RT is equal to the R naught is common, okay, 1 plus alpha into T. We get this equation. Okay, this is important for solving the problems. Okay, then for small change in temperature, the value of alpha is given by this equation. Alpha is equal to the 1 upon R naught dr by dt. This is the value of alpha. Alpha is equal to the 1 upon R naught dr by dt. For small difference in temperature, the value of alpha is this. This is also important. Then if you plot a graph of resistivity versus temperature, then graph is linear for high temperatures. Graph is linear means it is directly proportional. या पद्धतीने तो ग्राफ येणार आहे. Suppose this is the resistivity rho and this is the temperature small t, then nature of graph is like this for the high temperatures. And for low temperatures, the graph is non-linear. तो exact linear नसणार आहे. Linear means straight line passing through the origin. This result can be found in terms of a high temperature, and for low temperature, the graph is non-linear, means R is not exactly varies with a temperature. Okay, and this result can be found for the some metals also. Okay, then the next point is superconductors. Definitions is here important. Let us see the superconductors. What do you mean by the superconductor? Just we have seen that resistance of a material varies with a temperature. At particular low temperature, the resistivity of material becomes 0. that low temperature is called as critical temperature. That low temperature is called as a critical temperature. Okay? At low temperature, resistivity of the material becomes 0 and that material acts as a conductor. ते मटेरियल काय म्हणून ऍक्ट होतंय? कंडक्टर म्हणून ऍक्ट होत आहे. ओके. आणि मग जो कंडक्टर ही प्रॉपर्टी ओबे करतो त्याला काय म्हणायचंय? सुपर कंडक्टर्स म्हणायचं आहे. अँड द phenomena is called as a superconductivity. Superconductivity. What is superconductivity then? The phenomena at which the resistivity of a material becomes 0 at particular low temperature and the material acts as a conductor, then that phenomena is called as a superconductivity. And the conductor, that conductor is called as a, that material is called as a conductor. Okay? And this phenomena is very important because always the superconducting wires are used in supercomputers. Computers मध्ये काय वापरलेले असतात? नेहमी सुपरकंडक्टिंग वायर्स वापरलेले असतात. कारण त्याच्यामुळे काय होतं की त्या सुपर कॉम्प्युटरचा किंवा कॉम्प्युटरचा काय होत असतो? स्पीड हा इन्क्रीज होत असतो. देअरफॉर धिस फेनॉमेना इज व्हेरी इम्पॉर्टंट. ओके. की त्याच्यामुळे लॉस सुद्धा काय होतो? जो सिग्नलचा लॉस आहे, पॉवर लॉस आपण ज्याला म्हणतो, तो सुद्धा काय असतो? या मॅनरमध्ये काय असतो? कमी असतो. आणि देअरफॉर धिस फेनॉमेना, सुपर कंडक्टिंग फेनॉमेना इज व्हेरी इम्पॉर्टंट. अँड दॅट सुपर कंडक्टर्स आर यूज इन डिफरंट मेडिकल सायन्स इक्विपमेंट्स. सपोज MRI हे जे काही इक्विपमेंट्स आहे तिथं सुद्धा सुपर कंडक्टिंग केबल्स ह्या वापरलेल्या असतात की जेणेकरून त्याचा स्पीड हा काय होत असतो? तिथं इन्क्रीज होत असतो. ओके. दिस इज ऑल अबाउट द temperature coefficient of resistance and superconductors. Superconductors मध्ये त्याची definitions and its applications is important. This is asked for only the 1 mark. Let us see the example related to our previous point, temperature coefficient of resistance. See the problem related to the temperature coefficient of resistance. In this problem, we have given the values of alpha and we have to find out the resistance at particular temperature. Okay, see this problem. A piece of platinum wire, that is material here is platinum. This platinum wire has resistance of 2.5 ohm at 0 degree Celsius. Means first original resistance, so we can say here solution in data. First we have given the R naught, means original resistance of platinum wire is equal to the 2.5 ohm at 0 degree Celsius, means original temperatures, okay, is 0 degree Celsius. Its temperature coefficient of resistance is 4 into 10 raised to minus 3 per degree Celsius. Therefore, what is this quantity? This quantity is alpha. Okay? Alpha is called as a temperature coefficient of resistance. It is the constant and this is equal to the 4 into 10 raised to minus 3 per degree Celsius. Find the resistance of the wire at 80 degree Celsius. We have to find out the value of resistance at which temperature? At 80 degree Celsius temperature. Therefore, T is equal to the here 80 degree Celsius. Okay. Then which formula is used? Yes, R naught is equal to the R T in bracket 1 plus alpha into T. Just to have seen that. Okay. R naught is equal to the, here is formula is RT, sorry. RT is equal to the R naught 1 plus alpha into T. Okay. Therefore, RT is equal to the R naught is 2.5 1 plus alpha 4 into 10 raised to minus 3 into 80. Okay. Take as it is. Therefore, RT is equal to the 2.5 1 plus. Okay. Therefore, multiply it by 4 into 80. Therefore, it is equal to the addition पण आपल्याला करायची. Therefore, here is 0.0004. Okay. Therefore, here is 0.004. 10 raised to minus 3. Therefore, it becomes 0.004. Okay. Into 80. Therefore, RT is equal to the 2.5 1 plus 0.004 into 80. It becomes 0.32. 0.32. Therefore, RT is equal to the 2.5. This is 1.32. Okay. Therefore, it becomes 2.5 into 1.32. Therefore, RT is equal to the, take the multiplication of this. This become 3.3 ohm. This is the value of resistance of the platinum wire at 80 degree Celsius. Okay. This is the way to find out the value of resistance. Okay. Because here is 4 into 10 raised to minus 3 आणि ते आपल्याला ॲड पण करायचे. ही व्हॅल्यू आपल्याला डायरेक्ट ॲड नसती करता आली बरोबर ना. 4 into 10 raised to minus 3 आहे म्हणून आपण ती काय लिहिलेली आहे इन टर्म्स ऑफ दिस पॉवर इज इन टर्म्स ऑफ दिस देअरफॉर 0.04 into 80 and then it is simple. ओके. जेवढं कॅल्क्युलेशन्स ओरली आपल्याला होईल तेवढं कॅल्क्युलेशन्स आपण करायचे. नॉट नेसेसरी टू यूज द लॉग टेबल हिअर. ओके. लेट अस स्टॉप हिअर. सर्व विद्यार्थ्यांनी सर्व व्हिडिओ हे व्यवस्थित पाहायचे आहेत आणि चॅनल हे लाईक शेअर अँड सबस्क्राईब करायचे आहेत. असं आढळून आलेलं आहे की बरेचसे विद्यार्थी हे पूर्ण व्हिडिओ हा पाहत नाही आहे. तर तसं करायचं नाही आहे. पूर्ण व्हिडिओ हा व्यवस्थित पहा कारण त्याच्यावरच डिपेंड आपल्या ह्या एक्झाम ह्या असणार आहे. ओके. लेट अस स्टॉप हिअर.